There's a couple of things you need to take note of this example. First is that the given example is already the first derivative of a function. And then the second one is we are going to find the second derivative or the derivative of this function. Okay? We will derive or differentiate this function again once. Then the formula we're going to remember is the formula for quotient rule. So quotient rule says that if you have u over v, where u and v are functions of x, you will have to follow this formula, b squared, and the numerator will be v times the derivative of u minus u times the derivative of b, right? That's the derivative of u over v. Second one is the derivative of any square root number. Square root of u will be equal to 1, or derivative of u over 2 times the square root of u, right? So let's apply this. So by applying the quotient rule, d squared y over dx squared will then be the squared of the denominator, so that will be this one, 4 minus x squared. For numerator, it will be this one, since that's our b, 4 minus x squared, times the derivative of the above function. So what will be the derivative of that function? So for this one, the first term, that would be negative 4 times x. Second term is negative 2. Then the last term is 0, because the derivative of a constant is 0. So this is our du. That's our du part. This is our v. And this is our b squared. Minus u. So our u here is this whole function. Negative 2x squared minus 2x plus 4. And then multiplied by the derivative of this one, the v. Derivative of that is just the derivative of inside. So 4 minus x squared. So the derivative of 4 is 0. The derivative of negative x squared is negative 2x all over 2 times the square root of the u, which is 4 minus x squared. So, alright, we're done differentiating it. This is now the second derivative of a function, or the derivative of the first derivative. So all we have to do here on this part is just simplify it. And technically, this is already the answer. This is already a valid answer of the derivative of this one. So that is how you use the quotient rule.